Welcome back to the deep dive. We are going to try something a little different today.
Oh, yeah.
Usually we look at a trend over, a few months or even a year, but today we are zooming way in.
How far in?
We're looking at a specific 24-hour window, a single day.
Okay, I'm intrigued. Which day?
We are looking at Thursday, February 12th, 2026.
Ah, yes. A date that I think future historians of technology are going to end up circling, probably in red ink.
It really feels like the ground shifted under our feet. And I don't mean that in, the usual marketing sense.
Right, not just a new feature launch.
Exactly. We're not talking about a new logo or a slightly faster chatbot that can write a better haiku. I mean, the actual tectonic plates of the AI landscape moved while everyone was looking the other way.
They absolutely were.
Wow.
You have to remember the context of mid-February. It's so important. The entire narrative, everything you saw on social media, in the press,
Yeah.
it was totally focused on the OpenAI versus Anthropic tennis match.
It was a two-horse race.
Completely.
Ah.
It was all about GPT-5 rumors, this mysterious Orion project that was supposedly in the works, and whatever the latest Claude 3.5 or 4 update was. It was a very, very binary conversation.
Pick your team.
Pick your team, yeah. And then, without a big keynote, no fancy stage, no flashy demo video of a robot folding laundry, Google DeepMind just quietly walks up to the scoreboard.
And just posts a number.
Posts a set of numbers that, frankly, shouldn't have been possible yet. Nobody thought we were there.
It was a quiet drop, as you say, but the product itself is incredibly loud. We're talking about Gemini 3 DeepThink.
That's the one.
Yeah.
And I think the mission for this deep dive is to really figure out if this is just another bump in the graph.
Yeah.
Another incremental 5% gain that we see every few months.
Or something else.
Or if we've actually crossed a genuine threshold, a phase transition. Are we really looking at the shift from AI that can talk to AI that can actually truly think?
And to get there, I think we have to start with the noise. We have to start with the culture. Because you sent me a tweet that morning that I think just perfectly encapsulates the sheer hysteria of that Thursday.
Oh, I know what you mean.
It's from the AI commentator at Vazuman. I'm going to read this verbatim, but I might need you to act as my translator for some of the more esoteric internet speak here.
I will do my absolute best. It's a second language at this point.
All right, the tweet says, and it's in all caps, Gemini 3 DeepThink just brutally frame Mogged GPT and Opus, giving Sam Altman and Dario Amodei career-ending cortisol spikes.
It's poetry, isn't it? In its own very aggressive, very 2026 way.
It is intensely specific, but let's try to strip away the caps lock for a second. There is a very specific vernacular being used here that tells us a lot about the psychology of the market right now.
Sure.
Start with frame mogged. I think I know mogged is slang, but break it down for us in this context.
Right, so we are wading into the deep waters of internet subculture slang here. This isn't corporate speak. Mogged is derived from the acronym AMOG, which stands for alpha male of the group.
Okay.
In the context of 2026 AI Twitter, to mog someone is to dominate them so completely, so overwhelmingly, that they look physically small or insignificant by comparison. It's a visual, visceral term.
So it's a dominance hierarchy thing. It's not just we won the quarter or our stock is up. It's you don't even belong in this weight class anymore.
Precisely. It implies a total reevaluation of status. And the frame part of it is just as important. Frame refers to the reality you project, the lens through which everyone sees the world.
The narrative?
The narrative, exactly. So when they say Gemini frame mogged the competition, they're saying Google walked into the room and just shattered the reality that OpenAI or Anthropic were the undisputed leaders.
They broke the story everyone was telling themselves.
They didn't just win. They made the old story look foolish. It implies a public humiliation. It's a very visceral, almost violent description of a software release, which is fascinating in itself.
And then it gets physiological. Career-ending cortisol spikes. Cortisol, of course, being the stress hormone.
The fight-or-flight chemical.
Yeah.
The tweet is literally painting a picture of Sam Altman at OpenAI and Dario Amodei at Anthropic seeing these benchmarks and physically panicking, their bodies being flooded with stress.
Now, obviously, that's hyperbole. These are seasoned CEOs. They aren't actually, hyperventilating in a corner somewhere.
Of course not, but the fantasy of it is what's telling.
Yes. The fact that the community imagines them panicking tells you everything you need to know. It feels like a zero-sum game now.
That is the absolute key insight. The perception in 2026, rightly or wrongly, is that the AI frontier is a winner-take-all market. We're not talking about the old browser wars where, everyone gets a slice of the pie.
There's no room for second place.
The thinking is that there isn't. We are talking about billions and billions of dollars in training runs for a single model, a finite pool of elite researchers. I mean, maybe a few hundred people on the entire planet who can really push the frontier.
And massive winner-take-all enterprise contracts.
Exactly. So if Google has truly cracked reasoning, if they've genuinely built a Ferrari while everyone else is still trying to optimize a horse, then the competitors don't just lose a news cycle. They don't just have a bad week.
No, they have to tear up their entire roadmaps.
It's an emergency roadmap recalculation, as you put it. Everything they thought was true on Wednesday is now in question on Thursday.
And that's why the tribalism is so incredibly high. You see it in the threads you shared with me. The cheapatamps, who are fans of OpenAI trying to find flaws to claim contamination.
The Opelsels, the Anthropic fans, saying it's just a benchmark and doesn't matter in the real world.
And of course the Gemini chads taking a victory lap.
It's treated like a high-stakes spectator sport because the underlying stakes for the technology are seen as existential. It's a battle for the future of intelligence itself.
Okay, so that's the vibe, that's the mogging, that's the culture shock. But as we always say on this show, memes are cheap.
Very cheap.
Anyone can tweet, in all caps. We need to look at the receipts. Because usually when a company claims they've solved reasoning, you look at the fine print and it's just a slightly better chatbot.
And this is where the story pivots. This is where the memes stop and the data begins. Because Google didn't just tweet, they dropped a comprehensive technical report alongside the model.
And you've been through it.
I have. And looking at these charts, the theme is very, very clearly not about writing better poems or summarizing your emails faster. It's about something much deeper. It's about reasoning depth.
And the benchmark that everyone is circling, the one that seems to be causing the most heartburn for the competition, is something called RRC AGI-2. I've heard this described as the final boss fight for AI. Why does this one matter more than, say, the bar exam or the SATs?
This is probably the most critical part of the entire update. So ARC stands for the Abstraction and Reasoning Corpus. It was designed by Francois Chalet, a very prominent, very well-respected AI researcher at Google, specifically to stop AI from cheating.
Cheating by memorization, right, because that's kind of the dirty little secret of a lot of benchmarks.
It is the dirty secret. Most of the benchmarks we've used for years, like the bar exam or medical licensing exams or the SATs, they're all text-based.
And the models have been trained on the entire internet.
Which means they have almost certainly seen the questions or questions incredibly similar to them in their training data. So when they give the right answer, it's often not because they're thinking. They're just auto-completing based on statistical probability.
It's pattern recognition.
It's glorified pattern recognition. It's like the student who memorized the entire answer key but doesn't actually understand the subject matter at all.
And they'll fail the moment you ask them a question that's not on the key.
Precisely. ARC is designed to break that failure mode. It's entirely visual. It's not text-based. Imagine a simple grid of colored squares, like a little pixel art canvas.
Okay.
You're given maybe 2 or 3 pairs of examples. In the first pair, you see an input grid with a single blue pixel, and in the output grid, that blue pixel has moved 1 step to the right.
Simple enough.
In the second pair, an input grid with a red pixel, and in the output, the red pixel has moved 1 step to the right.
Okay, so I can see the pattern. The rule is objects move 1 step to the right.
Exactly. You, a human, induce the abstract rule from just a couple of examples. Then you're given a final test grid, which has, say, a yellow pixel, and you have to predict the correct output grid.
So I draw a grid with the yellow pixel moved 1 to the right.
And you'd be correct. Now, that's a trivial example. But the actual ARC puzzles get incredibly fiendishly complex. They involve concepts like gravity, symmetry, object permanence, sliding mechanics, repeating patterns, nesting, and containment.
Things that are intuitive to us because we live in a physical world.
We have priors. We have a built-in physics engine in our heads. The catch with ARC is that the AI has never seen these specific grids, these specific colors, or these specific arrangements before. The priors it needs to solve them are things like objects usually stay the same size, or things stop when they hit a solid wall.
Concepts, not just data.
Exactly. And LLMs do not have those concepts intuitively. They live in a world of text statistics. They don't know what gravity feels like. So ARC is essentially an IQ test for fluid intelligence. It tests adaptability and generalization, not knowledge retrieval.
Okay, so it's a pure reasoning test. So what was the state of the art before this drop?
This is what makes this story so dramatic. To give you the full context on why people are freaking out, In early 2026, the absolute best, most advanced frontier models, we're calling the unreleased GPT-5 class models, the best Claude models, they were all stuck at a hard wall on ARC AGI-2.
And what was that wall?
They were scoring somewhere between 30% and 45%.
That's a failing grade. On some of them, that's barely better than random chance.
It is a decisive failure. The consensus in the research community, I mean the serious consensus, was that breaking 50% would likely take another 2 years of fundamental research. It was considered the hardest nut to crack in all of AGI safety and capabilities research.
Okay, so that's the baseline. The best in the world are at 45% max. And what did Gemini 3 DeepThink score?
84.6%.
I'm sorry, can you repeat that?
84.6.
Wait, hold on. You said the best were at 45%, and this thing hits 84.6.
Yeah.
That doesn't make any sense. That's not an incremental improvement. In tech, usually see, a 10% jump, maybe a 20% improvement is massive. It gets headlines. Doubling the score on the hardest known benchmark in the field. It sounds fake.
It sounds like a typo.
How do we know they didn't just cheat? How do we know they didn't just train it on the test questions?
That was the immediate gut-level accusation from the GPTers on Twitter. Contamination. They leaked the test set into the training data. It's the first thing everyone thought. But this score was independently verified by the ARC Prize Foundation.
Okay, so a third party.
A trusted third party. They use a private, held-out test set that is kept under lock and key in a digital vault. The model had absolutely, positively never seen these specific puzzles before.
So it actually figured them out from scratch during the test.
It solved them. Cold. This is the structural jump that the viral tweet was referencing.
Yeah.
You do not get a 40-point game by just making the model bigger or throwing more GPUs at it. That gets you 5 points, maybe 10.
So this implies a new architecture, a different way of processing.
You get there by fundamentally changing how the model thinks. This is the first piece of hard evidence that the model isn't just mimicking text patterns anymore. It is performing genuine compositional reasoning. It's taking abstract concepts it knows like blue, slide, stop, inside, and fitting them together in novel ways to solve a problem it's never ever seen before.
That is genuinely unsettling. Because if it can do that on abstract colored grids, what else can it reason through? Because, colored grids are one thing, but the real world is a lot messier than a grid.
Well, you've just provided the perfect segue to the second benchmark in the report, which has a name that sounds like it was written by a marketing team for a sci-fi horror movie.
Laughs. Don't tell me. Humanity's Last Exam.
That's the one.
I saw this in the report. It sounds incredibly dramatic. What is this test actually measuring?
It's a brutal, custom-built test covering frontier-level graduate and postgraduate math, physics, and engineering problems. Think quantum mechanics, advanced circuit design, stuff like that. But here is the critical constraint that makes it so interesting and so hard.
What's the catch?
It is tool-free.
Meaning what, exactly? No calculator?
No calculator, no Python interpreter to run code, no calling out to a search engine, nothing.
So it has to do all the math in its head, so
Okay.
to speak.
In its neural weights, yes. It has to perform multi-step internal reasoning from start to finish. Think about how ridiculously hard that is for a standard large language model. An LLM, at its core, just predicts the next token, the next word.
Right.
If it makes one tiny arithmetic mistake in step 1 of a 50-step physics equation, that single error will cascade.
It's the butterfly effect.
Yeah.
The error propagates, and by step 50, the answer is just complete nonsense.
Exactly. The model drifts off the path of logical coherence. To solve humanity's last exam, the model has to hold an incredibly complex logical structure in its working memory for hundreds of computational steps without dropping the ball. It has to derive the math, remember the variables, substitute them correctly, and solve the physics problem purely through its own internal cognitive processing.
It has to maintain focus.
A very, very long chain of focus.
Okay, so what was the score in this one?
48.4%.
Okay, now that sounds low compared to the 80s we were just talking about. 48% is an F in any class I ever took.
Context is everything here. For this test, 48% is a new public state-of-the-art by a very wide margin. This test is specifically designed to be failed by systems that can't think.
So it's an adversarial benchmark?
Extremely adversarial. It ruthlessly penalizes any kind of shortcutting or shallow heuristics. The fact that it got nearly half of these incredibly difficult problems, right, purely on internal reasoning, without being able to run code to check its work, that's massive. It shows that the drift problem, that tendency for AI to lose the plot in the middle of a long problem, is being solved.
And if you want even more proof of this long-horizon reasoning focus, the report also makes a big deal about code forces.
Right. And for anyone who doesn't know, code forces is the big leagues for competitive programming. This isn't where you go to learn how to, build a simple website. This is where the human wizards hang out. The best programmers in the world compete there to solve algorithmic nightmares under extreme time pressure.
These problems are designed to be tricky.
They're designed to break your brain. They require deep insight into data structures and algorithms.
And Gemini 3 DeepThink has a rating there, an official rating.
It does. It competed and hit an ELO rating of 3,455.
Okay, you have to translate that for the non-coders among us. Is that good?
Is that good? Laughs. That is roughly human grandmaster level.
Grandmaster in programming.
Yes. For perspective, that puts it in the top few dozen human competitors on the planet. To get a score like 3,455, you cannot hallucinate. You cannot miss a single semicolon. You cannot have a subtle off by one error or a logic bug.
Because the tests are automated.
Exactly. If you make one tiny error, your code fails the hidden test cases, and you get a 0 for the problem. This score confirms that the model has the ability to maintain strict, precise, symbolic, logical coherence over thousands of steps. It's not just generating code that looks right, it's generating code that is provably logically sound.
And there was one more category, right? The Olympiads.
Yes, the International Science Olympiads for high school students, which are notoriously difficult.
These are the best of the best high school students in the world. The absolute peak. And the model achieved gold medal level performance on the written portions of the 2025 International Math, Physics, and Chemistry Olympiads. Again, this is formal problem solving under extreme constraints, not just retrieving trivia from Wikipedia.
Okay, so we have the mogging and we have a pile of benchmarks to back it up. But I really want to get under the hood here. You mentioned before changing how the model thinks. The sources all keep using this term System 2. We've heard this term thrown around before, but it feels more concrete this time.
Yes, this is the secret sauce. This is the core architectural change that allows a score to jump from 40% to 80% on a test like ARC.
And I know the term from psychology, Daniel Kahneman, his book Thinking Fast and Slow.
That's the one, the foundational text. Kahneman described human cognition as operating in two distinct modes. System 1 is fast, intuitive, automatic. It's effortless. If I ask you what is 2 plus 2, the number 4 just pops into your head.
I don't calculate it, I just know it. You don't think about it, it's a reflex. Or if you see a red light while driving, you hit the brake. You don't sit there and calculate the physics of the car stopping. It's an automatic response.
Got it. System 1 is autopilot.
Perfect analogy. Now, historically, every large language model we've ever built, from GPT-3 to GPT-4, and even the earlier Gemini models, they were pure System 1 machines. They were just predicting the next word based on the statistical likelihood from their training data.
Autocomplete on steroids.
That's the classic, and still the best, description. They weren't pausing to reflect, they were just flowing. They were riffing.
So when they would get a complex math problem wrong, it was because they were just blurting out the first number that sounded statistically plausible rather than actually doing the work.
Precisely. They were mimicking the output of reasoning without performing the process of reasoning. Gemini 3 DeepThink represents the first real scalable push toward what we're calling System 2 AI.
Which is the opposite. It's the slow, deliberate, analytical part of the brain.
The part you use to solve a complex logic puzzle or do your taxes. It requires effort, focus, and deliberation.
But how does a computer do System 2? I mean, does it actually pause? Does it sit there and stroke its chin, computationally speaking?
In a computational sense, yes, it does. It uses a technique that is becoming the new frontier. Inference time compute.
Inference time compute. Okay, unpack that phrase for me.
Sure. So usually when you build an AI, you spend a fortune, billions of dollars on the training run. That's the learning phase where it builds its world model. But when you use it, that's called the inference phase, it's supposed to be cheap and fast. You put in a token, you get a token out, milliseconds.
Fast and cheap, that's the business model.
That's been the model. Gemini 3 DeepThink changes that equation. It shifts a significant amount of compute from the training phase to the inference phase.
So it works harder when you ask it a question.
A lot harder, but only when it needs to. When you ask it a hard question, like a code forces problem or an ARC puzzle, it doesn't just give you the first answer that comes to mind. It engages in what the paper calls internal deliberation.
It generates hidden thoughts. Is that what they call it?
That's the term, yes. It's essentially generating tokens, having a conversation with itself, that you, the user, never see. It's formulating a plan. It's creating an internal scratch pad.
So it's literally talking itself through the problem.
Exactly. It might say to itself, okay, the user wants me to solve this grid puzzle. The rule could be about color or shape or position. Let me try hypothesis A. The rule is about color changes. If I apply that to the examples, does it work? No, that leads to a contradiction. Okay, backtrack. Let me try hypothesis B. The rule is about object rotation.
So it's simulating the outcome of a potential path before it commits to an answer and shows it to you.
It is performing what computer scientists call test time search. It is actively exploring a tree of possibilities, a tree of potential reasoning paths, and it is pruning the bad branches.
Pruning the bad branches, that feels like the key, doesn't it? The ability to self-correct.
It is everything. Older models were stuck on a single path. If they started down a wrong line of reasoning, they would just confidently hallucinate their way to the end. They couldn't recognize their own mistake. Deepthink can recognize internally, wait, this line of logic is flawed, and then stop, backtrack, and pivot to a more promising approach.
That is a fundamental shift. It's the difference between a student just guessing on a multiple choice test versus a student actually working out the proof on scratch paper, seeing a mistake, erasing it, and trying again.
And then verifying their own work before they hand in the test. That is why the ARC score jumped so high. It wasn't just guessing the pattern, it was systematically testing different rules internally until it found the one that perfectly fit all the given examples.
This moves us, as you said, from assistant to something very different. If it can reason, check its own work, and plan multiple steps ahead, that sounds like a collaborator.
Or even co-researcher.
And this is where we have to leave the abstract world of benchmarks and look at the real world. Because, benchmarks are great. Getting a gold medal in the Olympiad is cool. But can this thing actually do a job? Can it, pay the rent?
Right. And Google knew this question was coming, which is why they released a major case study with Duke University right alongside the model, specifically with the Wang Lab at Duke.
And this is where the rubber really meets the road. They weren't using Gemini to write marketing copy or plan a vacation.
No. They were using it to design entirely new semiconductor materials.
Which is an incredibly high-stakes field.
Unbelievably high stakes. Material science is notoriously difficult, primarily because the search space of possible materials is effectively infinite. You have the periodic table, 100 and something elements?
Sure.
And you can combine those elements in near unlimited ways, in different ratios, in different three-dimensional crystal structures. Finding a combination that is stable, conductive, heat-resistant, and non-toxic is like finding a specific needle in a universe full of haystacks.
And traditionally, that process takes what? Years of a PhD's life.
It takes months, sometimes years, of PhD-level labor just to identify a single promising candidate structure on a computer. And then you have expensive, time-consuming wet lab experiments to actually synthesize it and see if it works in the real world. It is a slow, grinding, expensive process of trial and error.
So how did DeepThink change that process? Because we've heard about AI for drug discovery and material science for years. What was different this time?
The difference was that System 2 reasoning capability. The Wang Lab used the model to drive the entire scientific discovery loop. First, DeepThink generated hypotheses for novel crystal structures that could have desirable properties. But, and this is the crucial part, it didn't just hallucinate a bunch of random chemicals that violate the basic laws of physics.
It checked its own work.
It used that internal deliberation we were just talking about. It would propose a structure and then reason about it, saying things like, this bond angle is likely unstable under pressure, or this structure probably won't conduct electricity efficiently because of the resulting electron band gap. It was actively pruning its own bad ideas before it even showed them to the human researchers.
So it acted as the first and most important filter.
It acted as the lead scientist on the project. It filtered thousands and thousands of potential candidates down to the handful that were most viable. It effectively said to the humans, don't waste your time or your expensive lab equipment on these 9,995 ideas. They won't work. But test these 5. These 5 have a real shot.
It massively compressed the R&D timeline.
Dramatically.
Yeah.
It turns a multi-year search into a matter of weeks or months. And now think about the economic value of that. Semiconductors aren't just computer chips in your phone.
No, they're everything.
They are the materials in solar panels. They are the cathodes and anodes in our batteries. They are the backbone of national security, telecommunications, and the entire transition to renewable energy.
So if you can use an AI to invent a new material that makes solar panels just 20% more efficient, or a battery that holds a charge twice as long,
You're not talking about $1 million discovery. You're talking about $1 trillion discovery. And this brings us all the way back to those career-ending cortisol spikes we talked about at the very beginning.
The brutal business reality.
Exactly. When we laugh about the slang, the mogging, and the cortisol, we are laughing about the perceived stress of the competitors. But why are they stressed? They're stressed because enterprise buyers, we're talking Pfizer, Boeing, NASA, the Department of Defense, they do not care about the personality of your chatbot.
They don't care at all.
They don't care if it can tell a good joke in the style of Shakespeare.
They want the results. They want the ROI.
They care about performance on mission-critical tasks. If Google's model can accelerate drug discovery or material science or aerospace engineering by 50% because of this unique system-to reasoning capability, every major R&D lab in the world is going to switch to Google Cloud tomorrow morning.
It's a completely ruthless calculation. Loyalty goes out the window.
It does. I think 2023 was the year of chat. 2024 was the year of multimedia, video, audio, images. 2026 is shaping up to be the year of the question, can your AI think?
And if the answer is no,
If you can't demonstrate deep reasoning, you lose the enterprise contracts. And if you lose the enterprise contracts, you can't afford to fund the next $10 billion training run. It becomes a death spiral.
it's a flywheel. A positive one for the winner and a negative one for everyone else. And that, in turn, triggers the talent war.
The hidden war, absolutely. We talk about the war for chips and the war for data, but the scarcest resource of all is brains. The researchers who actually build these things, the top 0.001% of global talent, they are mercenaries in a sense. They want to work on the frontier.
They want to be where the most exciting work is happening.
And they want to work with the smartest cognitive co-pilot. If you're a brilliant physicist, you want the AI that can help you win a Nobel Prize.
You want to work with the winner.
If Google is now perceived as the clear winner in reasoning, if they have the Ferrari and everyone else has the horse, the top talent will drain from OpenAI and Anthropic and migrate to Google, and that, of course, just accelerates Google's lead even further.
So I have to ask the big question. Is it game over? Is Google just the king now? Do we just pack up and go home?
The historian in me, the part that looks at the patterns of technology, says, almost certainly no.
The pendulum always swings back.
The frontier moves in cycles. We've seen this exact pattern play out before, just a few years ago. One lab ships a massive breakthrough. They look like invincible gods for 6, maybe 9 months. Remember when GPT-4 came out in early 2023?
Oh, absolutely. The conversation was over. Everyone thought OpenAI had won AI forever. It was done.
Exactly. It was an insurmountable lead. And then what happened? Anthropic came out with Claude 3 Opus, which leapfrogged it on some key benchmarks. Then Google came with Gemini 1.5 Pro and its massive context window. The competition is relentless.
So OpenAI and Anthropic will reverse engineer this.
They are already reverse engineering it. They will read the papers, they'll read between the lines, they will have their best people working around the clock to figure out how to do inference time compute efficiently.
And they're sitting on billions of dollars in cash. They aren't going to just sit on their hands.
Absolutely not. The question isn't if they will respond. The question is how quickly and how dramatically. Can they match this system-to-inference approach with their existing architectures? Or has Google found some kind of deep structural advantage, maybe something unique to their custom TPU chips that is genuinely hard to copy? That's the multi-billion-dollar question for the rest of 2026.
But for right now, today, in mid-February, Google has one massive advantage that goes beyond the technology itself, and that's distribution.
Yes. This is maybe the most important business lesson. Benchmarks don't change the world until people can actually use them. And Google didn't just publish a PDF in a blog post, they turned it on.
It's live right now.
It is live.
Yeah.
If you are a paying Google AI Ultra subscriber, this deep think model is in your pocket right now on the Gemini app.
So I can literally open the app on my phone and ask it to solve a complex physics problem using this new reasoning engine.
You can. And maybe more importantly, if you are a developer or a researcher at a big company, it's available right now via the Vertex AI platform as an early access program. They are flooding the zone with this new capability.
They've clearly learned the hard lesson from the last few years where they were perceived as being too cautious, too slow.
That old narrative of Google doesn't ship, that they just keep their best tech locked up in the lab.
That narrative is dead.
As of February 12th, 2026, that narrative is officially dead.
Yeah.
They are shipping.
Aggressively. So let's try to wrap all of this up. We started this journey with a viral, aggressive tweet about being MOG and giving competitors cortisol spikes. But what we're really seeing when you get past the memes is AI growing up.
I think we are seeing the goalposts of the entire field move. For a long, long time, the goal was simply make it sound human. The whole idea of the Turing test was based on deception. Can you fool a human into thinking you are real?
We've moved so far past that now, nobody cares about the Turing test anymore.
It's irrelevant. Now, the goal is make it smarter than a human at the hardest cognitive tasks we know. We don't want it to sound like us anymore. We want it to outthink us.
We've gone from just talking about intelligence to actually demonstrating it with verifiable receipts.
Yeah.
From the meme chaos on Twitter to the staggering ARC-AGI scores to the actual semiconductor breakthroughs at Duke, it's a full stack of evidence.
It is, but I want to leave you and our listeners with one final thought, a slightly more provocative one to chew on as we close out.
Please, lay it on me.
We are so used to thinking of AI as a tool. A better hammer, a faster calculator, a more powerful microscope. It's always been a tool that humans use to do their work. But look at that Duke University case study again, very carefully.
Okay, I'm with you.
The AI generated the initial hypothesis. The AI pruned the thousands of bad ideas. The AI proposed the final, viable structure. The humans in the lab, they verified it.
They were the auditors. They ran the final check on the AI's work.
Right. So my question is this. If we are truly entering the era of System 2 AI, of deliberate, creative, analytical, hypothesis-generating reasoning, at what point does the AI become the primary author of the discovery?
Wow. Yeah, if the creative spark, the novel insight, the logical leap that no human had made before, if that comes from the silicon, whose discovery is it? Who gets the Nobel Prize?
That is a question that our patent law, our academic institutions, and frankly, our human ego are not all ready to answer.
We are potentially moving from being the operators of our scientific tools to being the auditors of our own progress. That is an equal parts exciting and terrifying thought.
It is, I think, the defining transition of our time.
Well, on that existential bombshell, I think we are going to sign off. I want you to ask yourself today and for the rest of the week, are you doing System 1 thinking, just reacting, running on autopilot, or are you taking the time to do some real System 2 thinking?
And if you're too tired, maybe download the app and let the AI do some of that heavy lifting for you.
There it is. Thanks for listening to The Deep Dive. We'll see you in the future.
Goodbye, everyone.